Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Discrete Mathematics series and concerns functions. This guide introduces some important concepts of functions: the domain, codomain and range of a function. It shows you how to decide what is and what is not a function, and then how to categorize functions. Finally, it discusses which functions can be inverted. Introduction. Functions are a fundamental building block of higher mathematics and are not just the common mathematical functions like x squared or sine, but are also found in databases and symbolic logic. They can also be used to describe very simple situations. For example, in a shop, artichokes cost £1, broccoli costs £2 and cabbages also costs £2. Each vegetable has one price associated with it. In this guide you will see that a function is a way to associate each element in a set of vegetables, artichoke, broccoli and cabbage, with an element in the set of prices, £1, £2, £3. By using information about these two sets, this guide will show you how to categorize functions. Not every price has a unique vegetable associated with it. A £2 vegetable might be broccoli or cabbage, and not every price has a vegetable. No vegetable costs £3. This sort of information allows us to categorize the function and show that there is no inverse function in this case. Domain, codomain and range of a function. In mathematics, a function can be thought of as a machine which takes an input, often called x, and gives a unique output, often called f of x, said f of x. In order to use functions well, you should consider what sort of things can be inputs and what sort of things can be outputs. For example, the square root function f of x equals the square root of x cannot accept negative numbers, or, in the grocer's example above, no vegetable can cost £1.50. The set of inputs for a given function have a special name, the domain of the function. The set of all outputs associated with the domain is called the range of the function. The range itself is part of a bigger set called the codomain. Sets which are commonly used as domains, codomains and ranges are the set of real numbers and the set of integers. See study guide, different types of numbers. But a set can be any collection of objects and not just numbers. Sets are written as a letter, usually uppercase, or as a list of elements separated by commas and curly brackets, such as this. For example, in the grocer's example in the introduction, there are two sets, V, which contains the vegetables, and P, which contains the prices. These are written as V equals artichoke, broccoli, cabbage, separated by commas, in curly brackets. P equals £1, £2, £3, separated by commas, in curly brackets. A function takes an input, which is an element in the domain V, and connects it to an output, which is an element in the range P. A function might also be a mathematical procedure. See study guide, using functions. In simple cases, there is a neat way of visualizing them. In the above diagram, the domain is on the left, labelled V, and the codomain is on the right, labelled P, with the arrows that connect them representing the function f. The range comprises numbers on the right at which an arrow ends. Here, V is the domain and P is the codomain. As no vegetable costs £3, the range is the set 1 and 2, which is part of a subset of the codomain. In other words, 3 is in the codomain but not in the range. You could write the function mathematically as f connects V to P, which can be read as f connects V to P, with the colon meaning connects, and the arrow meaning to. Example: D is the set of numbers 0, 1 and 2. C is the set of numbers 0, 1, 4 and 10. And the function f of x equals x squared connects D to C. So f connects D to C. What is the range of f? Since f of 0 equals 0 squared, which equals 0, f of 1 equals 1 squared, which equals 1, and f of 2 equals 2 squared, which equals 4, the function is shown as this. So 0 in the domain connects to 0 in the codomain. 1 in the domain connects to 1 in the codomain. 2 in the domain connects to 4 in the codomain. So D is the domain and C is the codomain, but since no number in D goes to the number 10 in the codomain, C, the range of the set is 0, 1 and 4. Identifying functions. A function is like a machine. For every input there is a unique output. Think of a vending machine. Every code you put in gives an output, even if the output is invalid code or out of stock. Furthermore, if you type 245 into the vending machine, you get out a specific chocolate bar. The output has to be unique. You do not get a chocolate bar some of the time and bottled water at other times. Mathematically, a function cannot have many outputs for a given input. Some connections between sets are not functions, either because there is no output for every input, or because there are more than one output. This is known as a one-to-many relationship. A function connects every element of its domain to only one element of the codomain. Example: which of the following diagrams, A, B, C, represents a function? Firstly, A. This is not a function. The number -3 on the left in the domain has no connection to any value on the right. Diagram B is not a function. The number -3 on the left has two connections, -5 and 0 on the right. This is a one-to-many relationship. Diagram C is a function. Diagram C represents a function as each number in its domain on the left has a unique corresponding value in the codomain on the right. It does not matter that the 3 is not in the range, or that both -2 and 1 on the left go to 2 on the right. Types of functions. In the grocer's example, if a vegetable costs £2, can you tell what vegetable it is? Is there a vegetable for every price in P? In harder problems, it is helpful to categorise functions to answer such questions. There are 4 categories of function. Category 1. When there is a unique connection between every element of the range and an element of the domain, the function is called injective or an injection. An injection is also called a one-to-one function, as one element in the range connects to only one value in the domain. Category 2. When the range of a function is equal to the codomain, the function is called a surjective function or a surjection. Sometimes a surjection is called an onto function, as its domain maps onto the whole of its codomain. Category 3. A function which is both surjective and injective is called bijective. This is sometimes called one-to-one and onto. Category 4. A function may be none of the above. Example: classify the functions depicted by diagrams D, E, F and G. Diagram D is an injection because for each value in the range there is a connection to only one value in the domain. However, it is not a surjection and so not a bijection because the value 6 of the codomain is not connected to any value in the domain. Diagram E is a surjection because its range is equal to its codomain. However, it is not an injection and so not a bijection because 0 and 1 in the domain have the same value in the range, 7. Diagram F is not a surjection because the value 3 in the codomain has no connection with the domain. It is not an injection because -2 and -3 in the domain have the same value of 2 in the codomain. So it cannot be a bijection. Diagram G is a surjection because its range is equal to its codomain, and it is an injection because each value of the range is paired with only one value of the domain. Therefore, it is a bijection. Bijections are invertible functions. The study guide, Inverse Functions and Their Graphs, explains that an inverse function undoes what a function does. The function connects every member to its domain to an output, which is a member of its codomain. Then, an inverse function must undo this. It must take every member of the original function's codomain back to a unique member of its domain. Not every function is invertible. In fact, a function is invertible if and only if every member of the codomain has a unique connection with every member of the domain. In other words, a function has an inverse if and only if it is a bijection. Example: decide whether the functions in diagrams D, E, F and G have an inverse. D is not a surjection and therefore not a bijection, and therefore does not have an inverse. Specifically, there is no rule to map the -6 element of the codomain onto the domain. E is not a bijection and therefore does not have an inverse. Two numbers, 0 and 1, map onto 7. If there was an inverse that maps back from the codomain, then would 7 go to 0 or 1? This is a one-to-many relationship and therefore not a function. F is not a bijection and therefore does not have an inverse. G is a bijection and therefore has an inverse. Every element in the codomain has a unique element in the range that it can map back to. The inverse would look like the diagram on the right. Summary. Not functions. Type: one-to-many. Example: A maps onto 1 or 2, A maps onto 1, A maps onto 2. Functions: injection or one-to-one. Example: the function maps AB onto 1, 2, 3. A maps onto 1, B maps onto 2. Surjection or onto. Function maps ABC onto 1, 2. A maps onto 1, B maps onto 2, C maps onto 1. Invertible functions: bijection or one-to-one and onto. Example: the function maps ABC onto 1, 2, 3. A maps onto 1, B maps onto 2, C maps onto 3. Further guidance and information. If you have any further questions about functions or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592 761. Email dos.help@uea.ac.uk or visit our website www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science, available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.